The AWS status page is finally green. The Summary of Service Health says, all services are functioning normally. But on your phone, your apps are still spinning. Your website is still throwing 500 errors. And your engineering team is still on a frantic war room call that has been going for 6 hours. Why? If the cloud provider is back, why is the world still broken? There is a massive gap between the cloud provider recovery and app-level recovery. A status page green light doesn't mean your systems are functional, it just means the infrastructure could be functional. Today, we're doing a deep dive into the hidden, messy aftermath of a major cloud outage. When we talk about an AWS outage, we often focus on the big names, S3, DynamoDB, or EC2. But the cloud is a house of cards. When a core region like US East 1 goes down, it's not just about servers being off. It's about the Enigma of the blast radius. Services like IAM, Identity and Access Management, are core dependencies for almost everything else. If IAM is glitchy, you can't spin up new servers, you can't authorize database connections, and you can't even check logs. Even after IAM recovers, the thousands of microservices that rely on it are now in a corrupted state. They have stale permissions, failed tokens, and broken handshakes that don't just fix themselves. Reason number 1 for the delay, data consistency. In the cloud, consistently eventual is the rule. When an outage hits, thousands of transactions were half-finished. Maybe a database write was committed on the primary instance, but the synchronous replica never received it before the network link died. When AWS comes back, your databases perform a resync. During this time, your app might see zombie records, old data that was supposed to be updated. Or worse, mismatched ID counters. If your primary and replica are out of sync, your code might try to write a record that already exists. Restoring the cloud doesn't automatically repair your application's data integrity. Reason number 2, the throttling storm. Imagine a city where the power has been out for 10 hours. When the lights finally flicker on, everyone turns on their AC, their stove, and their charging cables at the exact same second. The grid immediately blows a fuse. This is exactly what happens in the cloud. Every single microservice in your architecture wakes up at once. They all try to re-establish database connections. They all try to pull their latest configs from S3. They all flood the health check endpoints. This creates a stampeding herd effect, a self-inflicted DDoS attack. AWS might be back, but its API endpoints are now buckling under the weight of billions of requests per second. Reason number 3, the DNS lag. To keep the global internet moving, your browser, your local router, and your ISPs cache DNS records. During a failover, your engineering team might have changed DNS records to point to a secondary region. But because of time to live, TTL, settings, those changes take time to propagate. Even after AWS recovers and you switch your DNS back to the primary region, some of your users' ISPs will keep serving the dead IP address for hours. Until their local cache expires, your app is effectively down for them, even if it's up for the rest of the world. Reason number 4, poisoned caches. If your app was trying to fetch data during the outage, it likely received an error 500 or a connection timeout. Modern architectures have multiple layers of caching, Redis, Memcached, and CDNs like CloudFront. If your error handling logic wasn't perfect, your app might have cached that error as a valid response. Now, the database is fixed. The network is fast. But your cache is happily serving a 500 error screen to every single visitor. The only fix? A manual purge of millions of cache keys, which itself can take hours and risk overloading the database again. Reason number 5, manual intervention. Cloud automations are great, but many systems don't auto-recover from a dirty shutdown. Managed services like RDS, Relational Database Service, might require a manual failback to the primary instance. Auto-scaling groups might have hit their termination protection or scaled down to 0 and gotten stuck. An engineer has to go into the console and manually click, scale, or reset for hundreds of individual services. In a complex microservice environment, the recovery playbook can be dozens of pages long, and every step requires human verification. Reason number 6, the regional debt. If you were smart, you failed over to a secondary region like US West 2. But failing back is often twice as hard as failing over. While you were running in the secondary region, you were generating new data. Before you can move back home to US East 1, you have to sync all those new records back. This reverse sync is a massive data transfer. Until it's 100% finished, your app is running in a split-brain state. You might have to run in read-only mode for hours just to ensure no data is lost during the move. Reason number 7, the queue backlog. Systems today are asynchronous. They use SQS, Kinesis, and Kafka to process messages. During an outage, these queues don't stop receiving data, they just stop processing it. When the system comes back online, you don't start from zero. You start with 10 million messages in the backlog. Processing that backlog takes time. If your consumer servers are slow, it could take days to catch up to the now. During that time, your users see stale data or delayed notifications. Let's look at a real-world example from a major US East 1 event. AWS technically had the core issue fixed within 4 hours. But major retailers were reporting checkout failures for 24 to 36 hours. Why? Because their internal search indexes became corrupted during the crash. They had to re-index millions of products from scratch. The cloud was back, but the application's intelligence was gone. This demonstrates that uptime is about more than just availability, it's about functional integrity. So, how do you prevent this long aftermath? It starts with circuit breakers. Your app needs to detect when it's being overloaded and fail fast with a friendly message. Stop trying to hit the database every 100 milliseconds. Implementation of exponential backoff with Jitter is essential. Instead of every server retrying at the same time, they should wait for a random amount of time, the jitter, to spread the load and prevent a second crash. Next, graceful degradation. Your app should be aware of its dependencies. If the database is down, show a static version of the product page from 5 minutes ago. Allow users to browse, even if they can't buy. If you keep the users happy with cached content, they won't keep hitting the refresh button. Uncontrollable refresh clicks are the #1 cause of extended recovery times for web apps. During recovery, your standard dashboards might lie to you. You might see 100% in-service instances, but your error rate is still 50%. This is the observability gap. You need deep observability, tracking the actual customer experience, not just the server health. Monitor your time to first byte and success rate at the edge, the CDN level. If the status page is green but the edge is red, you aren't recovered. The true financial impact isn't the outage itself, it's the time to recovery, or TTR. A 1-hour outage followed by a 10-hour recovery process is effectively an 11-hour outage for your business. Every hour your engineering team spends debugging ghost problems after the fix is money down the drain. Postmortems are not just about finding the bugs, they are about finding the recovery traps. How long did it take to purge the cache? Why did the database sync take so long? These are the questions that save millions. The AWS status page is a signal, not a guarantee. Recovery is a complex, multi-stage process, not a toggle switch. Data corruption, DNS lag, and poison caches are the true enemies of uptime. Resiliency isn't just about surviving the crash, it's about thriving during the recovery. Build your systems to be cloud-ready, which means being recovery ready. Cloud outages are a fact of life in modern tech. But the aftermath is within your control. Have you ever experienced a ghost outage where the status was green, but everything was still failing? Let me know your war stories in the comments below. Make sure to subscribe to @Cloud Decoded for more deep dives into the reality of cloud engineering and DevOps. I'll see you in the next deep dive.